All right, welcome to lesson 9.3.4, applications of the Pythagorean theorem. Today we're just going to be using the Pythagorean theorem as we've been learning here in the last few lessons to solve some problems. So let's get started right away here. First one, which is question 116. Here's what you're going to do. It's really not me doing a lot of this, it's going to be you doing most of this. So here's what I want you to do. You've got your right triangle here. You've got the A side and the B side are the two sides that are connected to the 90 degrees. So here's A, here's B. You're going to square both of those sides, take the square root of, add those together, and then take square root of it to find the third side here. So go ahead and you'll do that one. On letter B here, though, a little bit different on letter B. You'll notice that they give you the dimensions of the C side. You need to find the B side. So you're going to take this number and square it. You're going to take this number and square it. And instead of adding them together, you will subtract them to find this number. Then you'll take the square root of that to find your B side. Same thing goes for letter C here. They give you A, they do not give you B, but they do give you C. So you're going to take your C side, square it, your A side, square it, and instead of adding them, you'll subtract them to find your C side. Pause the video right there and go ahead and do that. When you're done, come on back. We're back in 3, 2, 1. All right, moving forward to the next page. You need to come to class with those answers because I'm not giving them to you. I can check those in class when you bring those. All right, the next one that you're going to do is Coach Kelly's third period PE class is playing baseball on this little diamond right here. The distance between each base on the diamond is 90 feet, so which means from home plate here to first base is 90 feet. From here to here is 90 feet, from here to here is 90 feet, and here to here is 90 feet. The question is Lisa's over here at third base and throws the ball across over to first base. This distance here is not 90 feet. We know that this is 90 feet, and we know that this is 90 feet. But we've got to find this. By the way, this makes, if you don't know, a right triangle right here. So we've got A and B both equal 90. You need to find C on that. So use your Pythagorean theorem to solve for how long that side would be. Pause the video, and when you're done, come on back. I'll be back in 3, 2, 1. All right, moving on to the next question. As you can tell, I'm telling you how to do this. I'm just not telling you, giving you the answers. That's something you're going to be figuring out. To make this whole long story short, this city called Wright City, some people in the city believe that it was named after its shape. They believe this is a right triangle. The question is, I'm not so sure it's a right triangle. Maybe it is. Kind of looks like it is. Kind of looks like, I don't know, maybe it is. But I don't know what that distance is right here, and I don't know what this distance is. I do know what this distance is. I can figure that one out. That's a 1, 2, 3, 4, 5, 6. But if I only know one side, I cannot figure out the other two sides. So what I need to do is kind of break this shape down. You'll notice if I take that shape and I highlight a little portion of this yellow right here, the height of this yellow part is 2. The distance here is 3. Those would be my A and my B sides. I know that this is a right triangle, so I can go 2 squared plus 3 squared will equal whatever that answer is. So you need to do that right now. The other thing you need to do is take and do this one, which I know the height of this is 3, and I know the distance from here to here is 4. So you're going to take your 3 squared plus your 4 squared to figure out what this side is. Hopefully that makes sense. Once you know what the length of this side is, square it, because this would be your A side if this really is a right triangle. So take this side and square it. Take your B side here and square that. And does this one plus this one equal, we know that this whole length here is 6, so that's 36. Does this one squared plus this one squared equal 36? So that's what you've got to work on to find out, and come to school and tell me, is that a right city? That is your objective. All right. Let's see if I've got any more for you. I sure do. This one's another one. You can see we're just kind of using applications and then helping determine things. This is a funny looking farm right here. Three shapes kind of make up this farm. And so what Clem and Clyde, who own the farm, have done is they've broken this in. This square right here is a cornfield right here. This rectangular field over here, they grow artichokes. And over here in this triangular shape, they do walnut trees to sell walnuts. So a fence goes totally around the farm, which means the fence goes from here to here, from here to here, from here to here. So far they've given you all these sides, from here to here. But here comes the tricky one. They have not given you this side. So you're going to have to use your Pythagorean theorem, solve for what is that side, which by the way would be right here. But solve for what this side is, you know what this is, and then tell me what is the distance around that complete farm right there. No, we don't need this side here, and no, we don't need that side there. Perimeter is around the outside of the whole farm. So you need to come to school and tell me what the perimeter of that is, and you're going to have to use the Pythagorean theorem to figure out what this side is, which would be the same as this side, and then add up the distance completely around that shape. What else do we got going on today? Oh, I love it. Next problem. Scott is at the top of a 75-foot cliff. So cliff goes straight up and down. So Scott's up here. He's at the top of a 75-foot cliff. Here's my cliff, 75 feet high. Okay, he throws a rope. Woo! Poof, over here to Mark, who's standing, and he's got 96 feet of rope. So we know the distance from here to here is 96. So we know this is 75. We know this is 96. The question becomes, is what is the distance, and this is a right triangle from here to here. So we know this is a right triangle, so we know that the 75 side, and we know this side, and we know the 96 side. So we've got to take the 96 squared, the 75 squared, and use those using your Pythagorean theorem principles to come up with what the B side is. So do that and bring that to class. By the way, I hope you pause the problems on 118, 119, 120, where I didn't stop you. If you didn't, go back and pause it where you need to solve those problems. Finally, we move on to the very last problem. We've got 3 logs. Those log lengths are 19, 11, and 21. I want you to take those logs, put them together, and tell me whether that makes a Pythagorean theorem. Then, another girl, or no, it's still the same girl, has logs that are 9, 11, and 21. I need you to tell me if those 3 logs make a right triangle. So you're going to tell me if these 3 make a right triangle and if these 3 make a right triangle. So you're doing 2 problems here in 1. All right, and I believe I'm being nice to you here. I think I have one more, but I'm skipping it. Yep, not doing that one. So I was correct. This was your last problem. Finish those up. Make sure you answer all these, and we'll see you in class tomorrow. Bye-bye.